Good morning, dear students. My name is Ferhan Mazher, and today is 27th of April 2022. Right now, I am with the 11th Cambridge class, and the subject we are studying is Physics 5054. Today, we have set our heart to solve ATP paper. We call it paper 4, and we have selected May June 2014 4-2 paper. This paper 4 belongs from the zone 2, or you can say the variant 2. So let's start this paper, and here we go. So the question paper is coming up on screen. So May June 2014 4-2 paper. Time allowed is 1 hour. We call it paper 4. The first question coming up on your screen. A student investigates a floating wooden rod. The wooden rod is placed in a tall beaker. A rubber band around one end of the rod makes it float vertically as shown in the figure 1.1. So it's basically a wooden rod, and here we have the rubber bands, and when we put it in the water, this tall beaker, we put it, it has water, and we put this rod in this beaker. So this rod floats in this water. On the figure 1.1, mark and label the length L of the rod above the water. So above the water means from here till here. Okay. So we have to mark it with the letter L. So let me show you. I have done that. So you can see here I have marked it. From here, my arrow has gone little up, but your arrow should not go above this point. Okay. From here to here, and label it L. Okay. The next question. Explain why it is difficult to measure the L. You see, it's difficult to measure this length because you cannot bring the scale here, exactly here. When you will try to measure this length, your scale will be here, outside the beaker. And when it will be outside the beaker, then there will be a gap. There is a distance between this end of the rod and this meniscus also. So it's difficult. Another thing is that this rod is little, it is not stable. This rod is in water. So whenever you come near this, it will start, you can say, a little bit moving up and down. So it's difficult to measure exactly the length. So let me show you my answer. Rod moves up and down. Explain why it is difficult to measure. The rod moves up and down, so it's difficult to measure exactly the L value. Okay. Describe a method of measuring the L accurately. So how you can measure this L accurately? You know, we can use a rod who has already graduations on it. Graduation means the marks which shows this the reading on the scale. So we should use a rod which is already graduated. It has mm, like a scale. It has numbers written on it. Let me show you my answer, and then we will see. Mark the scale on the rod. That's the meaning of the mark scale on the rod. Top point will be considered 0 centimeter. So consider the top, this top. Consider this top as 0. Put 0 here, and whatever will be here, that's the L value. So let's check the marking scheme first. Correct length clearly marked. Okay, we are done with that. Anyone from rod moves in the water does not float vertically. Yeah, this is another problem, that the rod will not be vertically. It might be little tilted. Sides of the beaker obstruct. The sides of the beaker are also obstructing. A clear explanation of why parallax error occurs here. Because the rod will be inside the water and the scale will be outside the beaker. So there is little distance between them. So when you will try to measure what is the length, so obviously there will be chances of parallax error. Practical method stated, for example, mark the water level on the stick. Mark the scale on the stick. We have answered that mark the scale on the stick. Ruler held in the clamp close to beaker, close to rod. Length measured using a caliper. Okay. Here, clear practical day, for example, remove and measure before placing in the water, note the water level. View perpendicularly, subtract two readings, depth measure on caliper. We can use the depth measure also. You know that the vernier caliper has a tail which is used to measure the depth. So he's talking about that. So let's move to the next part. He says the student increase the number n of the rubber band on the bottom of the rod and measures the L for which the value of the n exam figure 1.2 is the student's result. So when n means the number of the rubber bands. So when there is one rubber band, the L value is 8.5, and when there are three rubber bands, the L value is 6.8. The more the number of rubber bands you are putting on, the length is gradually decreasing. Okay. So 7 rubber bands, 3.5 centimeter, 9 rubber bands, 1.6 centimeter is the L. L means the length of the rod which is outside the water. So on the figure 1.3, plot the graph of L in the centimeters on the y-axis against the N on the x-axis. Start your graph from the origin. Draw the line of the best fit. So here you have that graph. On the x-axis, I have to represent the number of the rubber bands. And on the y-axis, I have to represent the length of the rod which is outside the water. So let's do this. Okay, so this is the table. So the first thing which I will do, let me show you. The first thing which we will do, we will label the axis. So the y-axis has L in centimeters, and on the x-axis there is N. N means the number of the, the number of the rubber bands. And then we will plot them, and we will join them. So the table is given to us. So at one rubber band 8.5. So at one we will, let me increase the size. So at one it will be 8.5. At one it will be 8.5. Okay. Then at three 6.8. At three, this is a three. We will have 6.8 value. Yeah. Then you have five. You will at five you have 5.1. This is the five. So at five you will have 5.1. Put a dot here. Then at seven you have 3.5. At seven, this is a seven. At seven you have 3.5. Yeah. And at nine you have 1.6. 1.6. So this is, put these dots, and then we will join them with a line of the best fit. That line of best fit I have drawn with the pencil, so it's not that clear. The line of the best fit is not clear. It's basically a curve. Okay, it's not that clear in this diagram, but I can show you. Let me reduce the size and I will show you. This is going like this. This. Okay. So we're done with this. I said describe the relationship between L and N. As N increases, L decreases. Inverse relation is between L and N. So as the N value is increasing, the L value is decreasing. So that's the relationship between them. So let's have a look at the marking scheme. He says the axis labeled quantity and unit scales linear. Y-axis 2 centimeter equals to 1, and on the x-axis 2 centimeter equals to 2. Points plotted accurately within the 1/2 of the small square. Best fit straight line drawn. Okay, negative gradient and decrease as n increases. Inverse relationship. Okay. So don't use the word they are inversely proportional. Okay, just say inverse relation. Never use this word inversely proportional. Okay, for inversely proportional, the shape of graph is different. He said draw a line of the best fit. Okay, I have tried to join them with the curve, but he said draw the line of the best fit. You can draw a line of best fit. Okay, so let me show you. Let's draw a line of best fit. Let me take out the snipping tools. So let me take this. And let me open the paint and paste it here. So let's draw a line of best fit. You see all the points. Little bit here. Okay. Because I have drawn the line, I have drawn the curve there, but then after looking at the marking scheme, we have to draw the line of the best fit. So actually draw a line, okay? So one point is here, the one point is here, this point is almost there. So let me reduce the size. No. So you can see this is how you draw the line of the best fit. It's easy peasy. Okay. There is a use the graph to estimate the smallest number of bands needed to sink the rod. To sink the rod. When you will sink the rod, the height will be 0. When you will sink the rod, the height will be 0. So that will be some 11. This is the 11 point something. And that will means 11 bands. So how many bands will be needed? 11 bands. Then their question is, so how many bands are needed? 11 bands. Explain why it is important to use identical rubber bands. Identical rubber band means that every time you put a band, you are actually counting the number of bands, but actually you are putting a certain amount of mass. You are giving a certain increment in the mass or weight or load, and they are pulling the rod downward. So the rubber bands should be identical because so every time you put a band, there should be a same increment in the mass or weight. Identical rubber bands increase the mass of the rod uniformly. Yes, that is the answer. So let's have a look at the marking scheme. Same mass weight increases by same amount each time. Fair test, yes, then you can do the fair test, yes. Okay, so we are done with the question number we are done with the question number 1. Now we are going to the next question. That's question number 2. A student investigates the use of the ammeters in the circuit state, the quantity measured by an ammeter. You know, the ammeter can measure the EMF, the ammeter can measure the voltage drop. So, oh, sorry, we are talking about ammeter. So the ammeter can measure, sorry, I told you about the voltmeter. The ammeter can measure, ammeter can measure current. It can tell you the presence of the current. Ammeter can measure the current. The voltmeter is used to measure the voltage drop and the EMF. By mistake, I said voltage drop and EMF. The ammeter can measure current. Make that correction. I by mistake said voltmeter and voltage drop and the EMF. Okay. Explain why it is important for an ammeter to have a low resistance. Because the ammeter is connected in series, and if its resistance will be high, it will increase the resistance of the circuit, and that will decrease the current. So if the resistance of the ammeter is high, that will change the current flowing in the circuit. So the resistance of the ammeter should be low. It is connected in series with the resistor, so its resistance should be low. Otherwise, current coming from the battery will become very small if its resistance is high. Or you can say small, not very small, means small. Okay, so let's have a look at the marking scheme. The ammeter is used to measure the current, and low resistance does not decrease the current much. High resistance would decrease the current. Low resistance ammeter reads a larger value than high resistance ammeter. Current is higher, very little potential difference across it. Okay, so we are going to the next part. He says the figure 2.1 shows an analog ammeter. State the reading on the ammeter. State the reading on the ammeter. Okay. So what is the reading? This is 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, and this is 0.7. So 0.6, 0.62, 0.64, 0.66, and 0.68, and it's between them. So it will be 0.67. It's 0.67. 0.67. The reading is 0.67. 0.67 ampere. Okay. So let's have a look at the mark. 0.67 ampere is the answer. Okay. Next question is a school has both digital and analog ammeter. Suggest one advantage of using a digital ammeter rather than an analog ammeter. The digital ammeter has a very good advantage that it has the reading is given on a display, electronic display. So when the reading is given on a display, it is very easy to read. Obviously, the measurement, the reading will come on a display. So it's very easy to read. Another thing is that when the reading is given on the display, then there is no chance of the parallax error. So let's have a look. In digital, no parallax error is present. Okay. And it's easy to read. Yeah. No parallax error, needle does not stick, easier to read, measure current, easier to change range, low resistance. Figure 2.2 shows a simple circuit. A student connects three similar ammeter, he's talking about ammeters, at X and Y and at Z. The ammeters give slightly different reading. Explain why all the ammeters should give the same reading. You see, there is only one path for the current from the positive terminal of the battery to the negative terminal of the battery. So because there is one path of the current, so the amount of current which came out, same amount of current will go back, and there is one path of the current. So the three ammeters should read the same. They should give the same measurement because from all these 3 points, the current flowing is same. My answer is coming, the current coming from the battery has only a single path. So current at X, Y, and Z will be same. Then the question is suggest a reason for the slight difference in the three readings. There might be some slight difference in the readings because you know some ammeters might have zero error in them, and that can be the one reason. Some of them are a little bit faulty. Some meters might have zero error in them. Okay, that's my written answer. So let's look. Meters not identical, the meters are not exactly the same. Zero error in the meter, different calibrations. So there can be calibration error. So we are done with the question number 2. Okay, so we are going to next question. He says an experiment is carried out to investigate refraction of light through a glass block. Figure 3.1 shows a rectangular glass block. A ray of light is incident at the P at an angle of incidence of 40. The angle of refraction in the block is 24 degree. On the figure 3.1, draw the line to represent the normal at the P and the refracted ray. Okay. So they are talking about basically this diagram. So what I will do, I will first of all draw a normal here, and then we will make that refracted line here. And that angle of refraction is also already given. That angle of refraction is supposed to be 24. So let me show you my answer. Where is my answer? So you can see this is that diagram, figure 3.1. And this is the ray which is coming here. The first question they ask us to do, the first thing they ask us to do is to draw a normal at the P. So put a protector here at this point P, and with the help of protector mark 90 degree. I put this dot and do join this. This will be normal with this surface here. At this point, this is the normal. Normal means a line which will be making 90-degree angle with that face. So this gray line is making 90-degree angle with this face. So it is normal at this point. So then with the help of with the help of your protector, measure this angle with the normal. This should be 24 because he said in the question that the angle of refraction inside the block is 24. So put a protector here, mark the 24 degree. I put a dot here and join it up till this point AC. The name of the point is B. The question which they have used is that draw the normal at the P, the refracted ray, and the angle it makes is 24. Okay, then their question is the lower face of the block is labeled XY. So it's already labeled XY. You can see that this has been labeled as XY. This is already labeled as XY. Then what they want is on the figure 3.1, continue the normal to meet the XY, label this point A. So we have to continue this normal, and when it cuts this XY line, I will name it as A. You can see I have named it as A. Then they say on the figure 3.1, continue the line of the refracted ray to meet the XY, label this point as B. So this refracted ray, continue this. When this cut this XY face, we will name it as B. Okay. Measure the AB and the PB. We have to measure how much? AB and the PB. So just put a scale here and measure how much is this AB. I have measured it and measure what is PB. So you see the AB will be 2.8 and the PB will be 6.8. 2.8 and 6.8. Then he says on the figure 3.1, continue the line of the incident ray to meet the XY. Label this point as C. So this incident ray, just continue it. I continued with the dotted line. When it got the XY point, I have labeled it as C. Measure the AC and the PC. We have to measure which length? AC. AC and the PC. Measure these lines. Okay, just write them here. Theory suggests that the refractive index of the glass is given by the ratio AC multiply PB divided by AB multiply PC. Just put these values here. Calculate the ratio, give your answer to the suitable number of significant figures. Just put these values here. AC value is 5.1 multiply PB value is 6.8. The AB value is 2.8 and the PC value is 7.9. Put these values, you will get 1.6 final answer. So the refractive index is 1.6. Then the question is on the figure 3.1, draw a line to represent the ray of light that emerges from the block. Label this line L. Okay. So this light ray, when it will come into this air, it will be bended away from the normal. So I've drawn this and I have labeled it as L. So you can see the whole diagram on your screen. I have labeled this emerging ray as L. So let's have a marking scheme. 2.8, 6.9. So our answers are right. 2.8, 6.9. Okay. Then there is 5.3, 8.2. Approximately they are right. And 1.6 will be the final answer. So our answer is also 1.6. Okay. So we are going to the next question. The next question is question number 4. That was the original diagram. An experiment is carried out to determine the density of the glass used to make microscope slides. Figure 4.1 shows a stack of 10 microscope slides. Figure 4.2 shows full size view of the stack of the microscope slides. So from the top view, you can measure the length, you can measure the width, and you can see here the 10 slides have been stacked. By taking the measurement from the figure 4.2, determine the average volume of a microscope slide. State clearly any measurement taken and show how the volume is calculated, giving your answer to 2 significant figures. 4-mark question. Let me show you my solution. So we have measured how much is the length. This is the length, the width, and what is the height. So 7.5 centimeter is the length, the 2.5 centimeter is and the thickness is 1 centimeter, and there are 10 slides here. So one slide will be 1 by 10 centimeters. So the volume will be length into width into height. It will be 7.5 into 2.5 into 0.1. And that will be 1.875, 1.9. So when you round it off to one significant figure, or you can say 2 significant figures. So if I write 2.0, then it has 2 significant figures. So the final answer is 2.0. So our answer is right. By taking measurements from the figure, determine the average volume of a microscope slide. State clearly any measurements taken and show how the volume is calculated, giving your answer 2 significant figures. So we are done with this. The last question is explain why a stack of 10 slides is used rather than just one slide. You see, if you take 10 slides and you find their height and then you divide it with 10, so that will give you the thickness of one glass slide. And that is a more accurate method because you take the average thickness. This gives average value of thickness of one slide, which makes the measurement more accurate. Then the last question is state and any additional equipment needed to find the density of the glass. You know, we need to measure the mass of the glass. We know the mass, we know the volume. Another thing which I need is to measure the mass of the glass. And for that purpose, I need a balance. The spellings are wrong here. It should be balance. Okay, BALANCE, balance. So let's look at the marking scheme. Make thickness of one slide, height, volumes. That's more accurate. Slides are thin. Slides may vary in thickness. Gives average value for thickness of slide. I need scale, or you can say balance. So my dear students, today we have done May, June 2014 for 2 paper. This was a ATP paper, and we have done this, and I hope that you will be able to understand it. And if you find this video interesting and informative and useful to you, share the link of this video with your friends and onto your Facebook account and onto your Instagram accounts. So thank you very much, everyone. Have a good day. God bless you all.